This week, we will start with the last cycle, which is the synthesis of phenytoin. Phenytoin is a drug that is sold under the brand name Dilantin. It's an anti-seizure drug that controls the epileptic convulsions. In ordinary doses, phenytoin does not have a sedative effect and does not impair consciousness, unlike barbiturates that had been used earlier. If you look at the general scheme of phenytoin synthesis, you can see that it's composed of 3 steps. The first step is the benzoin condensation, where 2 molecules of benzaldehyde will become condensed to form a 1 benzoin molecule. This reaction will need a catalyst, which is the thiamine chloride. This benzoin compound will be oxidized to benzyl compound in the second step. The last step is another step of condensation, where benzyl is going to be condensed with urea in order to synthesize the diphenylhydantoin or phenytoin. Let's start with the first step, which is the condensation of benzoin. In this reaction, benzoin will be produced by the dimerization of 2 molecules of benzaldehyde. This reaction has a complete atom efficiency, where all atoms in the benzaldehyde will remain presented in the product. Make sure that the benzaldehyde used is a freshly distilled benzaldehyde because it's easily oxidized to benzoic acid, and this can prevent the desired reaction from happening. This reaction does not occur spontaneously. It needs a catalyst. This catalyst is needed to render the aldehydic carbon acidic, so that it can be deprotonated and function as a nucleophile in order to attack the second benzaldehyde carbonyl. For more than 100 years, the only species that had been found to satisfy the requirements for an effective catalyst of the benzoin condensation was the cyanide ion. However, it was discovered later that the conjugate base of a thiazolium salt was also an effective catalyst that is added reversibly to aldehydes and destabilize it. So that thiamine was used here because it contains a thiazole unit. If you look at the thiazolidine ring in the thiamine compound, you can see that the hydrogen in the second position of the ring is acidic. So many reactions can occur at this point. Keep in mind that the thiamine compound is a heat-sensitive compound and may decompose if heated too vigorously. So, instead of running the reaction at elevated temperature for a few hours, we will allow the reaction to proceed closer to room temperature for at least 24 hours. In this reaction, water is needed, but not too much water because this will force the benzaldehyde out of the solution, preventing an efficient reaction, and not too little water because this will prevent the thiamine from dissolving. Weight 1.04 grams of thiamine hydrochloride. In a 100 ml Erlenmeyer flask, Add 1.04 grams of thiamine hydrochloride. Add to it 3 ml of water. Shake well till the thiamine hydrochloride totally dissolved. Now, start adding 8 ml of ethanol from a purette filled with ethanol, 95%. Now, add 3 ml of 10% sodium hydroxide, also from a purette. Shake well. And finally, 7 ml of benzaldehyde. Make sure to mix between each addition. Now close the flask using parafilm and allow it to stand at room temperature at least overnight. Now we will collect the crystals using Bachner panel and then start washing them with 7 ml of 50% ethanol and several portions of water. Rinse it with some water. Now, add the 7 ml of 50% ethanol. Now, put your crystals on a filter paper to dry for the next lap.